Hello.
Hello.
Yeah. Can you hear me?
Yeah.
Okay. Noah is also joining, right?
Yeah.
Okay. So today we'll start factorials and we'll look at some theory that you might have seen before. I don't know. Uh, when do you guys go for the camp?
Uh,
Sunday.
yeah. Sunday.
So are you going on Sunday or Saturday?
I can check calendar. Um,
Okay. Saturday is 6th, Sunday is 7th. So Saturday you guys are free, right?
Yes. Yeah.
Okay. So we'll do one class today and one class on Saturday. And I think after that you guys can come back from the camp and then we'll continue. Okay.
Okay.
So factorials, and we'll also talk about something called P-adic valuation. You might have seen the term somewhere, but may not know it, right?
Yeah, I've heard of it before.
Okay. So the first thing is basic definition of factorials. N factorial is simply 1 into 2 into 3 to n. And by convention, we say 0 factorial is equal to 1, right?
Yeah.
Uh, Now, we'll get started with a definition here. Uh, Let P be a prime number, and let N be a positive integer. We define we define the p-adic valuation of N as the greatest non-negative integer k, non-negative integer k, such that p power k divides n. And we will write k is equal to v of Pn. This is just notation. So what this means is that v of Pn is the exponent of p in the prime factorization of n. Do you understand what I'm saying?
Uh, yeah. Oh,
So basically, it's the highest power of a prime number that appears in that number n, right? So
yeah.
if n is 24, right? V of 2 of 24 will be what?
Uh,
2,
Uh,
3,
yeah.
because
Yep.
it is 8 into 3, so 2 power 3 into 3, right?
Yes.
And V of 3 of 24 will be what? 1.
Yeah. Yeah.
Obviously, this notation is only making sense for prime numbers p, right? So you're
Yeah.
finding the p-adic valuation of n for a particular prime number, you're finding what is the power of p that appears in that n, right?
Yeah.
If that prime does not appear in n, then the v of p of n will be 0, right?
Yeah. Yeah.
Okay, so let's look at some of the basic properties. So first property is that if n is written as p1 power alpha 1, p2 power alpha 2, and so on till pk power alpha k, then v of p of I n is equal to alpha I, right?
Yeah.
Basically, each
Yeah.
prime number, its p-adic valuation is the exponent that appears in the factorization, right?
Yeah.
And if p is not equal to pi, then p of n is 0. Correct? If p is not one of
Oh,
these prime numbers, right?
Yeah.
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 And obviously v of p of n is 0, no then.
Yeah.
Okay. Now, if m and n are positive integers, then m divides n if and only if v of p of m is less than equal to v of p of n for every prime p. Think about it. V of P of M means the power of P that appears in M, right? Highest power.
Oh, yeah.
And the same prime number, if you're looking in N, the highest power that appears is called V of P of N, right?
Yeah.
If M divides N, then obviously the power here should be bigger than the power here, no?
Yeah.
It cannot be the other way around.
Yeah.
If this has three powers of 2 and this has only two powers of 2, then M cannot divide N.
Yeah.
For many of the prime numbers, it might be that the V of P of M is equal to V of P of N. Because any prime number that doesn't appear in any of them will have zero value of this, right?
Yeah.
Uh, yeah.
But for any prime number that appears in both of them, it is impossible for M's p-adic valuation to be bigger than N's.
Yeah.
Are you understanding?
Yeah.
Yeah.
This is common sense only. You just have to know what is the meaning of this. That's all.
Mm.
Right?
Yeah.
Okay. The third one is if A and B, okay, I'll write it on the next page. Third property is if A and B are positive integers, then for every prime P, V of P of LCM AB is equal to the maximum of V of P of A and V of P of B. And similarly, V of P of GCD AB is equal to the minimum of V of P of A and V of P of B. Think about it and make sure that you understand why.
Um,
Yeah.
Remember how you calculate LCM and GCD, right?
Yeah.
When we
yeah.
do LCM of two numbers, we compare their prime factorizations, and whenever it is any prime number appears in them, you take the highest possible power, right?
Yeah.
Yeah.
And that final thing becomes the LCM, right?
Mm.
So V of P of the LCM should be the maximum value of the V of P's, right?
Yeah.
For the individual numbers, right?
Yeah.
Whichever one is the higher number, that is the value of V of P of LCM.
Yeah.
Similarly, for GCD, it's the opposite because there you take the lowest possible common exponent, right?
Yeah.
Noah, are you understanding?
Yeah.
Okay. Then we have if A and B are positive integers and P is a prime, then we can say that V of P of AB is equal to VP of A and VP of B, the addition, and VP of A plus B is greater than equal to minimum of VPA plus not plus, minimum of VPA and VPB. Think about the multiplication part first. That is kind of obvious,
Yeah.
Oh, yeah.
right? Because when you multiply, the powers get added. So when you do p-adic valuation of the product, it will be the addition of the individual powers, right?
Yeah.
For any prime number P. And when you add the numbers and you do periodic valuation, so for example, let's take example. A is equal to 24, B is equal to 36, right? So this is 2 cube
Yeah.
into 3 power 1, and this is 2 square into 3 square, right?
Uh,
So when we are doing, let's find out V of 2 of A. What is V of 2 of A?
uh, it would be 3,
And what is V of 3 of A?
1,
And what is V of 2 of B?
2,
And V of 3 of B?
2.
Right. So we know the individual values here. Now we calculate A plus B. A plus B, you see, is 60, right?
Yes.
A plus B is 60. And 60 is basically 5 into 12. So 5 into 4 into 3. So 2 square into 5 power 1 into 3 power 1, right?
Yeah.
So V of 2 of A plus B, what is that?
2.
2. Is it greater than equal to minimum of V of 2 of A and B?
Yeah.
Because the minimum value is actually 2, right?
Yeah.
V of 3 of A plus B
1.
is 1, and minimum value of this is 1, right?
Yeah.
V of 5 of A plus B is 1,
1.
but V of 5 of both of them is 0, right?
Yeah.
So 1 is greater than equal to greater than minimum of these, right?
Yeah.
Notice that the equality happened when we were talking about primes that both of them had, right?
Yeah.
Correct?
Yeah.
And
Yeah.
also equality happened when V of P of A was not equal to V of P of B. For example, when V of 2 of A was not equal to V of 2 of B, then V of 2 of AB, A plus B, was equal to this minimum, right? What I'm saying is this. We are saying this, right?
Yeah.
What I'm saying right now is if V of P of A is not equal to V of P of B, then V of P of A plus B will be equal to minimum.
Oh, yes.
But if V of P of A is equal to V of P of B, for example, V5 of A was equal to V5 of B was equal to 0.
Yeah.
But then V5 of A plus B was greater than minima, right?
Yes.
Do you understand what I'm saying right now?
Yeah.
Yeah.
But when we did for 2 and 3, they became equal, right?
Hmm.
That
Yeah.
was because for 2 and 3, the p-adic valuation of A and B were unequal.
Yeah.
But when they became equal, then here there was an inequality. Right?
Yeah. Yeah.
Like these are the 4 properties that you need to know. You don't need many more properties. I hope you have written down all of them.
Yeah.
So we don't need to know many properties. We just need to learn how to apply things. So there are 2 more formulas that you need to know. These are Legendre's formula. This guy is a mathematician, famous mathematician. Legendre's
Okay.
formula 1. The first formula is let P be a prime number and n is a positive integer. Then V of P of n factorial. He has given us a formula to calculate this. Okay. So that comes out as a summation of k goes from 1 to infinity of floor function of n by p power k. Does everyone know what is floor function?
Yeah.
Yes.
So for example, floor function of 1.1 will be 1, right? Floor function of 1.3 is also 1. Floor function of 2
Um,
2.
2.
is 2. And floor function of minus 1.5 is how much?
-2.
So the idea is that this always gives us the greatest integer which is less than or equal to x. Right?
Yeah.
So you will get the biggest possible integer which is smaller than or equal to itself.
Yeah.
So here the biggest possible integer smaller than minus 1.5 is -2. Right?
Yeah. Yeah.
Whenever you give
Yeah.
integer inputs to a floor function, then you get the same answer. For example, GIF of -3 is -3. This is also called GIF, by the way, greatest integer function or
Okay.
floor function. So if I am saying GIF, I mean this only, right? So what we are saying in this formula is that V of P of n factorial will be the sum of n by P power 1 plus n by P power 2 plus n by P power 3 and so on till n by P power k, and this keeps going on forever, right?
Yeah.
Now think about it. It is actually quite easy to understand. So let's calculate, for example, V of 2 of 6 factorial, right?
Yeah.
So actually what is 6 factorial? It is 6 into 5 into 4 into 3 into 2 into 1, right?
Yeah.
We can calculate this answer by just looking at it also, because we realize 1, 2 comes from here, right?
Yeah.
Two
Yeah.
2's come from here and 1, 2 comes from here, right?
Yeah.
So how many 2's are there? 4,
Um,
correct?
yeah, 4.
Yeah.
So
Yes.
answer should be 4, right?
Yeah.
Now we will verify the formula. The formula, Legendre's formula tells us that it should be n by p power 1 plus n by p power 2 and goes on like that forever, right?
Yeah.
And each of these is a floor function, right?
Yeah.
So n is what? N is 6 factorial. So it is 6 factorial by prime number is 2. So 2 plus 6 factorial by 2 square plus 6 factorial by 2 cube plus 6 factorial by 2 power 4, so 16, plus 6 factorial by 32, right? Plus 6 factorial by 64, right?
Mm.
And finally, 6 factorial by 128 when you do, you will realize that 128 is bigger than 6 factorial.
Oh,
Do you see that after a while it becomes bigger?
isn't
Yeah.
6 factorial like,
Yeah, I have made some mistake in our calculation here.
isn't it bigger than 128?
This is 2, 6 factorial is this only. So 2 into 3 into 5 into 2 square into 3 into 2 power 1 into 1, right? Okay, our answer should be correct, right?
Yeah.
Because I'm getting
Yeah.
how many powers of 2? Only 4, right?
Yeah.
The highest power of 2 that comes here is 4 only.
Yeah.
Okay, so let's see what happens from here. So,
Oh, because
but,
it's 6. It'll be 6, not 6 factorial.
oh yeah. Oh
Uh,
yeah, yeah, I'm making a mistake. I'm putting 6 factorial. Right.
uh,
That's why it was becoming so big. Yeah.
Yeah.
So that's why it was making no sense.
Yeah.
So here you don't have to put n factorial, otherwise the answer is huge. Right?
Yeah.
This is the formula. It is n by p power 1, p power 2, p power 3, and so on float functions. And now you see the answer will come because this is going to give us 3. This is 1.5, but floor function of that is 1, right?
Yeah.
And everywhere ahead, here all of the values are 0,
Mm.
right?
Yeah.
So basically, as soon as it becomes a fraction between 0 and 1, the floor function becomes 0, right?
Yeah.
yeah.
So this formula is very easy and it tells us how to find the p-adic valuation of a prime number in n factorial. The way to write it is k is equal to 1 to n infinity n by p power k floor function, right?
Yeah.
Yeah.
And now we'll look at the second formula. So let p be a prime and let n be equal to ak p power k plus ak minus 1 p power k minus 1 and so on till a1p plus a naught, right? And if you think about it, this should remind you of something.
Oh, modular. Wait, no.
This is the
Yeah.
base p
Yeah.
representation
Yeah.
of n, right?
Yeah.
N was in base 10, and if you rewrite it like this, you will be able to say what is the base p representation of n, right?
Yeah.
That would be this number basically.
Yeah.
Base p. Correct?
Yeah.
Then what we can say is Vp of n factorial can also be written as n minus s of p of n divided by p minus 1, where s of p of n is ak plus ak minus 1 plus a1 plus a0, or sum of the digits of n in base p.
Uh,
Do you understand?
yeah.
So basically, this gives us an alternative way to do the p-adic valuation of n factorial, right?
Yeah.
Yeah.
Now here the sum of the digits of base n in base p, if you know, then you can do n minus sum of these digits by p minus 1. And let's now confirm it for our previous example, right?
Yeah.
We had done it for 6 factorial, right? V of 2 of 6 factorial, right?
Yeah. Yeah.
And we had got an answer as 4 from first formula. Now what we'll say is ki if my n is 6, then what is the s of n, s of 2 of n, right? We need to find.
Yeah.
For that, I need to
Uh,
write n in base 2, right?
yeah.
So let's quickly do that. 6 and base 2. So when I divide, I get a quotient of 3, right? And remainder 0, right?
Yeah.
When I divide it again, I get a quotient of 1 and a remainder of 1, and that's it, right?
Yeah.
So the number is 110, right?
Yeah.
This is the number in base 2, 6,
Yeah.
correct? So
Yeah.
S of 2 of 6 is 2, right?
Yeah.
So my
Mm.
the formula is V of P of n factorial is n minus S of P of n by P minus 1, right?
Yeah.
So it is 6 minus S of 2 divided by 2 minus 1,
Mm.
correct?
Yeah.
So right now we have not proved this formula, but you don't need to know the proof right now. You can find it. That's totally up to you. But what we will do is whatever we have learned so far, the definitions and properties, we'll start with some questions and we'll try to understand it a little better. So try this one first. Find the greatest positive integer n so that 3 power n divides 70 factorial plus 71 factorial plus 72 factorial. You can use any of the concepts we have done today. Don't try to do it by old methods. Try to apply what we have learned today.
Really?
Uh,
Hmm.
I got 32.
32.
Yeah.
You're missing something, some small values.
Still busy. Um,
Okay, I think you have just calculated V of P of V of 3 of 70 factorial.
Yeah,
But what about these?
because it's the minimum. No.
Think about it. Like
uh,
the property that we used earlier was for A plus B, right?
Yeah, can you not call A like 70 factorial plus 71 factorial? And
Yeah,
then
you
B
can do
70
that.
factorial?
70 factorial plus 71 into 70 factorial plus 72 into 71 into 70 factorial, right?
yeah,
So this is 70 factorial common 1 plus 71 plus 71 into 72, no?
yeah.
So this is also might have factors of 3, no?
Uh,
You have done this
yeah.
part correctly, but what about this? You have found V of 3 of 70 factorial. That's correct, 32. But you have missed out on factors of this. By the way, this can be written as 1 plus uh, 71. Yeah. Uh, 1 plus 71 plus 71 into 71 plus 1, right? So this becomes 71 square plus 71 into 2, right? Plus 1, right? Is
Mm,
everyone seeing what I'm saying?
Yeah,
yes.
So isn't this like square of 71 plus 1?
yeah,
So basically this thing is 72 square actually.
yeah.
So there are 4 powers of 3 that are there inside it, no?
Mm.
Correct?
Yeah.
Yeah.
So the answer for n will be 36, not 32.
Wait, but can't you use the formula that says VP of A plus B is the minimum of each one?
We can think about it. What will happen if you try to apply that?
So
VP
Um,
then,
of what is your A and B?
oh, oh,
You will have to apply it to these two. But then
yeah,
what about this third one?
yeah. Let's see.
I mean, it's not fully fitting that formula, no?
Yeah,
It is much easier to just make it like this into like this, no? A into B.
yeah.
And
yeah.
then use the fact that you have to sum up the powers, no? Obviously.
Hmm.
Use the other version, AB,
Yeah,
because here are 3 terms and here this is 2, right?
yeah.
Yeah.
Okay, next one is find the greatest prime divisor. Prime divisor of 29 factorial plus 33 factorial.
Like common divisor or just of, oh, wait. Plus.
You don't have to ask that. Prime divisor of the
Um,
sum. I hope everyone realizes that this is the same thing.
Yes.
Right. So now, let's look at this part, inside part. Can you think of a good way to simplify it so that it becomes something nice?
Like, uh,
Basically, we want to figure out how to simplify this. Obviously, I don't want to multiply and all, right?
Yeah.
yeah,
So basically, the expression is this: x into x plus 1, x plus 2, x plus 3, right?
Yeah.
What grouping should I do?
X plus 1 and x plus 3.
No, you should always group x with x plus 3
Oh, yeah, yeah.
because that gives us a common thing, no?
Yeah.
yeah,
You get x squared plus 3x in both cases. See,
Yeah.
yeah,
Um,
you're getting x squared plus 3x here, and you're getting x squared plus 3x plus 2 here, right?
yeah,
yeah.
So this is clearly becoming x squared plus 3x whole square plus 2 into x squared plus 3x, right?
Yeah.
And we had a 1 outside, no? 1 plus.
Yeah.
So what is this becoming, see?
X squared plus 3x plus 1.
Whole square, right?
yeah.
Yeah.
So that is a very standard factorization. And because it is fitting in this pattern where x is equal to 30, we can say this is 30 square plus 3 into 30 plus 1 whole square.
Yeah.
So which is equal to 991 whole square.
Yeah.
So we are getting 29 factorial and 991 square, right?
Yeah.
Now all we need to figure out is what is the greatest prime divisor of this, right?
Yeah.
For 29 factorial, the greatest prime number that will divide it is 29.
Yeah.
Now we need to figure out what is 991. Is it prime or is that does it have bigger prime divisors and all?
Um,
How do you check whether a number is a prime or not?
With it.
um,
Use that method to figure out whether 991 is a prime or what is the largest prime divisor of it. 991 is a prime actually.
Uh,
Till where do you have to check? Till which prime do you have to check divisibility?
Square root.
So
Yeah.
square root of this, you should know what you have, till where you have to check. I think 32, 33 only you have to check, no?
Yeah.
Yeah.
Any prime up to 32, 33. So all the primes up to that you have to check whether they are dividing it perfectly or not, right?
Yeah.
Yeah.
So then if you check that, you will realize that this is a prime number. So the greatest prime divisor in this product is simply 991,
Uh,
right?
yeah.
Is it clear? This question doesn't use any of the concepts we learned today, but it's a simple
Yeah.
question only.
Yeah.
Okay. Let's look at this one. The number 100 factorial divided by 10 to the power 50 was written as an irreducible fraction. Find its denominator. I hope everyone knows the meaning of the word irreducible.
Um,
Like simplest form.
What did you say?
Like it's in its simplest form.
Yeah, it is in its lowest terms or simplest terms. Nothing,
yeah.
there is no common factor left, right?
Yeah. So, yeah.
Here you should use the concept we learned today, P-adic
Yeah.
valuation.
Yeah.
E.
Tell me what is V of 2 of 100 factorial?
That's 7,
Uh,
You will get
94.
it by doing this, right? 100 by 2.
yes.
94.
But basically this process only you have to do it.
Yes.
Yeah.
It is definitely bigger than 50,
Mm.
Yeah.
right?
Yeah.
V of 5 of 100 factorial is how much?
Um,
11. Wait, no.
Be careful.
Not 11. Uh,
It's 24.
22. Oh. Okay.
Check.
Yeah, 24.
Noah, are you following?
yeah.
this is 24 and this is greater than 50, around 90 or something, right?
Yeah.
So the numerator has 2 power greater than 50 and 5 power 24, right?
Yeah.
And the denominator has 2 power 50, 5 power 50.
Yeah.
So this 2 power 50 will be completely cancelled by this, no?
Mm.
And it will be left on the top, no? Powers of 2 will be left on the top.
Yeah.
Yeah.
But the 5 power 24 will be cancelled like this, right?
Yeah.
So when you reduce it to no common factors, the number should look like this, right?
Oh, yeah.
Yeah.
The denominator is 5 power 26. Correct?
Yeah. Well, I made a mistake. Pretty much, I
Hmm.
did using 10, which
Hmm.
isn't a prime. So I
Hmm.
got the wrong answer, but why would it give you the wrong answer?
If you are doing it using 10, V of 10, then what are you writing here? Is
So
10 power
then,
50.
because if you take V of 10 of 100 factorial, you get
Hmm.
11. So then,
Are there only 11 tens in 100 factorial?
no.
1 second, let's
No.
think about it. 100 into,
Oh, because it doesn't count for the 5 and the 2.
right. All the
Uh,
all the tens like this will give 110, right?
yeah.
100 gives two tens, and then 90, 80, and all of them will give us 110s, right?
Yeah.
Till 10. So already there are 11, but what about so many other numbers which will give us zeros?
Yeah. So
Like
that's
2
why.
into 5 and 12 into 15 and so on, right?
Yeah.
So this is going to be incorrect anyway, right?
Yeah.
So that's why it's not coming.
Yeah.
Okay, write down these questions. Try these before Saturday.
Okay.
On Saturday, we will do some more problems and we'll solve these. So, what is the least number of factors to cross out of 99 factorial so that the product of the remaining factors ends in 2. Tell me if you understand the question.
Uh,
See, 99 factorial has lot of numbers in product form, right?
Yeah.
yeah.
What is the lowest number of them that you can remove, right?
Oh.
You have to cross them out. Some of those numbers you have to remove so that the remaining thing that is left over, the product of that ends in 2.
Uh,
And you have to try to remove the least number of factors, right?
Yeah.
yeah.
There are 99 numbers, you can remove any number of them, but how many definitely you have to remove so that the remaining product ends in 2. Correct?
Yeah.
Yeah.
Okay, next question is find the smallest positive integer n such that n power n does not divide 2008 factorial. And question 6 is a set X has the property P and X is a subset of positive natural numbers, has the property P if every non-empty subset of X, non-empty subset of X has as its has as its sum of elements a composite number. This word, the phrasing of this problem is not very good. I will tell you what it means. The set X of positive natural numbers will be said to have the property P if every non-empty subset of X, the sum of the elements of that is a composite number. Right?
Oh, okay.
Hey.
The set X can have many subsets. Whenever you take a non-empty subset of the set X, what ends up happening is that if you add up all the elements of it, it should become composite. Right?
Yeah.
If that happens for every non-empty subset of X, then the set X has the property P.
Yeah.
Now we have to say, prove that the set Y, which is equal to 113 factorial plus 2, comma 113 factorial plus 3, comma, and so on, 113 factorial plus 15. This subset has the property P. Basically, we have to show that whenever you take a non-empty subset of Y, the sum of its elements is always composite.
Yeah.
Right? So these three problems, try it out. We will discuss the solutions on Saturday and we'll do some more problems before your camp.
Okay.
Okay, that's all for now.
Okay. Thank you.
Bye.
Thank you.